All right, I think we got fair amount of people here. Let's get started. And I will be the host today. So let's see. Um, so this is the Ron Wisey and Continuity Weisenschim's office hours. And as a member of the CNCF, we have to abide by the CNCF Code of Conduct. And I strongly encourage everyone to use the raise hands feature whenever you want to talk about something. And I will just raise your names when in order of the raise hands feature. So let's get started. Let's see, recurring topics. First, we want to welcome new members. And if someone wants to introduce themselves here, this is your chance.
I think we cannot hear you, Jorge.
Yeah, I can't hear.
No.
It's okay. Oh,
hello.
I think now, yeah, now we can hear you.
Okay, no, I can't hear you. Give me a second. Can you hear? Okay, I'm going to present myself. I'm Jorge. I joined Docker last week, so I'm here. I'm going to be working with Georgie here. Yeah, and I'm going to be contributing to Run Wisey. At least that's the plan.
welcome, Jorge. It's really nice to see you here. Anyone else wants to introduce themselves?
Hello, everyone. Can you hear me? Yeah, my name is Kent, and I'm from Shanghai, China. So currently, I'm working on the Kubernetes and especially the SIG scheduling. And we are now approach some ways like extend the kube scheduler with Wasm. So I guess I can learn something from the meeting. And yeah, that's all.
Welcome, Kent.
Yeah.
All right. Anyone else? Awesome. So let's see. So could I ask you to put your name to the attendee list in the document, your name and your company. And if you don't have a link to the document, I paste it into the chat. All right, I think that's all for the recurring topics. Let's move on to the open discussions, and that's the part I'm mostly excited about. So first item on the open discussion, we have James on update and on distribute using OCI artifacts. And there is also a link to Run Wisey issue, as well as a Google Doc.
Cool. I might just share my screen for the doc and I'll introduce it quickly. And then I have a quick demo. It's maybe like a minute and a half, 2 minutes. And then we'll open it up for discussion. If you don't have a link to the doc, I think I pasted in there. I don't know if it's gone through yet, but all right. Okay. Cool. So just a quick introduction. So there's been a little bit of discussion on several different issues around how do we distribute these? How do we distribute the WASM components and modules? And so I've been playing with a few different solutions that were kind of thrown out there across the different issues. I've collected all those in the alternative section down here. So if you're interested, we can discuss them a little bit afterwards about some of the pros and cons of those. But after working through a few different prototypes, I came up with this proposal and looking for feedback on it. This is complementary to a couple other proposals that are in the WARG repository. That one is here. It's proposal for an OCI content source in the back end. So you publish through WARG, and then it ends up in an OCI artifact that can be consumed by something like Containerd. And then Radu has also posted something similar. They're very similar to how they talk about how this would be stored in the back end. The important thing I want to call out in this document is like, I'm not proposing any particular media types or anything like that. I just wanted to demonstrate how this might work in Containerd. There's a couple problems with the way that or challenges that we're faced with Runwazi today. I'm currently trying to add Windows support to this, and I have Windows working, but the way we're publishing the images, we have to have this multi-arch manifest. So then we have to have two different Docker images, even though the only thing we're distributing is this WASM component. And this WASM component doesn't really care what platform it's running on. And so why do we have two different images with just a single component in it? So we want to try to make that, platform independent. There's another open issue here where the WASM modules are actually in the root file system where the WASM module, the WASM runtime is running. And so we don't want, potentially don't want to have that there. It's not needed. There was some concerns about maybe being able to introspect its WASM component. I'm not sure what the security consequences are there, but potentially how do we, eliminate that? That's not really something that needs to be there. There's no way currently for the runtime to pass the information about 3 or 4 different components that all need to be composed together into a single component. And so right now, like if you look at the root file system, there's no way to determine if these are just configuration files or if they're actual just WASM components without maybe inspecting the items themselves. And so the goal of this is to create a single artifact that's cross-platform, store them in the OCI registries, and have them be able to be pulled by runtimes like Containerd. We should be able to use all the existing OCI, capabilities. Each WASM component should be uniquely identifiable. So if we have 4 or 5 WASM components that are composed together to make a single app, we don't want to put those all together and store the big bundle of the component, because then we're going to have to store that in all these different places. We can reduce storage capacity by putting them in, by just storing individual components. And then we want to, either the runtime or the shim should be able to stitch these things together to provide them. And then we should also have a root file system that doesn't contain the WASM files. And maybe just has, other additional items like certificates and configuration files for the runtime, like flight and spin configurations. So what I came up with, I'll zoom in just a little bit here, and then I'll go into a demo so you can see it. But essentially we can take an artifact, we can do an image push. It goes up to the OCI artifact, and we have component 1, 2, and 3, and they're all independently stored. You do CTR pull or Containerd pull. You say, hey, this is platform WASI, and Containerd will just go and store each of those individual components as individual blobs on the file system. Now, if somebody came by and pulled a different image, and that image had C2 and C3 and C4, it wouldn't re-pull C2 and C3 because it already has it locally. So we get that benefit of the unique storage. And then finally at CTR runtime, it's going to pass that information to the shim. The shim composes it together and then executes the WASM runtime. So that's kind of what it looks like. And then I will take a moment and switch over to the demo and maybe answer a question or two if people have questions. Okay. So I'm going to make that big enough. Is that big enough to see? Okay, so I have a few of these manifests up there. One is a component and one is the core module today. Run WASI only supports core modules right now. And so I have the whole workflow working with that, but I prototyped it with the components. So I'm using the regctl. This has already been pushed up to the registry manifest. And the important things that you'll see here are this is a media type here of an image. The configuration, and this is where it's still up for conversation here, but it's a type WASM module JSON. And so behind the scenes, it's actually just an image config. And I'm not sure how exactly we're going to handle that, but in the specs right now, they pass that media type. There is, since we are creating in container, there is kind of a scratch layer. In the new image spec, there's this OCI scratch, and I reused it as kind of like a reusable base layer that has nothing in it. And then there's 3 individual components here. So you can see there's 3 different components, and they're individual. They each have their own digest and will get pulled when we go. So I'm going to skip ahead. And if I do a CTR pull, you'll see if I pass platform WASI, it goes and grabs those, and then it individually downloads each of those. And I had done this once before, so they already existed, and so it was super fast. So that's kind of what it looks like for components. There's the image config, the individual components, and that one scratch layer. So this is a WASM module. So for folks who aren't familiar, there's components, and components is something that's kind of a moving target right now. And you can take multiple components and bring them together. There's also a WASM core module, and that WASM core module is what we use today. It's based on the current WASM spec that's out there, and it assumes everything's kind of all together and compiled together. And so that's what I'm showing here. Same layout. I gave it a slightly different digest name down here at the bottom, called WASM module -v1 WASM. And so that's just a single component. So, and that's what Run WASI can run today. And then at the very end here, what I will do is I pull that same type of thing super fast because already exists. And then I'm going to go ahead and run it. So I also tweaked Run WASI to handle this situation. And you can see I've now pulled the module with containerd and passed it off. And what's interesting is this is actually running on Windows. So you can see the little prototype of kind of how I got it going. The base of this all works, whether it's Windows or Linux. Windows is actually a little bit more harder because there's some extra files that are required for the image thing, but that same exact image can be tweaked to run on Linux. And so that is the demo. Please take a look at I'll share back this document here, but please take a look at this document. It outlines that, shows the sample manifest, and talks through a bunch of different scenarios here. There are some open questions that I have. Oh yeah, I also mentioned kind of like a phased approach for moving forward with this. And we can talk about that in a second, but I want to start opening up questions. And then I have a bunch of open questions for some things that, as I was thinking through it, came up. So, and then finally, alternatives of like some of the different prototypes that I went through and challenges that I faced when doing that. So. Cool. Osaka or Joe.
Yeah.
Go ahead.
That's awesome to see, James. In the demo, when you execute that image, is it just a WASM module or is it WASM component?
When I actually execute it, I'm using a WASM module. But I did get the components passed over to the shim, and I have another prototype that shows stitching those components together. I didn't implement it in the shim just because it was going to take more time, and I had learned what I needed to. So, but yeah.
Right, that's what I figured, because currently I don't think Runwasi can execute WASM components, even if
Yeah.
WASM high.
Yeah. Yeah, it's actually not too much of a change, I think, to get it to work that way, but I didn't need to do it for the demo purposes.
Yeah, I actually have an open discussion. The next question is about how we adopt the WASM components. Maybe we can
Okay.
talk about. Does anyone else have any questions?
So I have one question regarding the configuration layer that you include. What do you expect to include in that configuration file? Or for example, in the future, there are config files that, I don't know, can tweak applications and things like that. Is that the purpose, or do you have already a use case for that?
Yeah, so currently the configuration file is, I think I called it out in here. Yeah, so currently I just made up a WASM component config.json, but the way that Runwasi works today is that it expects that to be an image configuration file, just like out of the OCI spec. So even though I called it something different here, it is just an image spec.
Okay.
And so I think that's an open question for me as to like, how do we handle that and what do we do with it? I kind of mentioned that here. I'm not sure if Brian has any thoughts there, but we do pull some fields off of that in Runwasi and use them to configure the runtime. But you're right, there are some extra configuration components and files and things that are needed. And so I don't have a great answer for that right now.
Yeah, I think because, sorry, I should have raised my hand. Sorry. I think
Likewise.
since we're passing down these references to artifacts, we are able to tell the Runwasi, here's what the media type of this is, and basically let the shim implementation deal with that. So you, for instance, with the Slight shim, that has its own configuration format. There could be a media type specifically for that the Slight shim will pick up on and use that instead of having to include it in the rootfs. Yeah.
Yeah, I think that's kind of what I was thinking as well. Go ahead, David.
So one of the architectural differences, or one of the not architectural, like Arc OS differences that we had in some of the Slight images that we were building were like cert bundles. Because we were going off of Scratch, there weren't any cert bundles there. So like if we were going to make outgoing calls over HTTPS, we wouldn't be able to trust the responding HTTPS endpoint. So have you considered laying down any files or how that could work so that it would be kind of platform independent?
Yes. For those, that's this question here around like, how do we have specific platform specific rootfs's? One idea I had, so I'm not sure how useful this is or like how common that pattern is going to be. If it's just those configuration files for Slight and other runtimes like that, WASM Edge or something, then I think passing that as a configuration file and passing it the same way we are to the modules, and the runtime could pick it up and handle those. I think that kind of makes sense for those configuration files. for things like certs and other things like that. One idea, which I don't know if this is a good idea or terrible idea, was you can tie a subject descriptor to the OCI manifest, and Containerd, if it knew that, could go look at an index, like a manifest index and or an image index, and go and select the right one for the OS. And so you could provide, if that subject was there, you could provide like a custom OS for that particular runtime. I don't know if that's a good idea or not, but it's definitely something that could happen.
So the subject descriptor on it, I mean, it almost seems like it should be like a tar-gzip layer. Is it a good idea or a bad idea that we would add information into the configuration? So you're using the image config right now. But if we had a custom config that contained like, hey, this like a Linux key subsection, and then under that subsection, this layer is what we're pointing to, or this layer we want to lay down on the file system, like after scratch or something.
Yeah, that's it. Yeah, if there's enough reason to not reuse the image configuration and we come up with our own, then I think we could potentially do something like that. I think a lot more experimentation needs to happen to identify that.
Yeah, I want smarter people to tell me that's dumb.
yeah.
what we should do.
Brian, go ahead.
I think in the case, I think certs is a very special case. Probably in most cases like this, we're going to want to configure the host to do things in a way that you want the host to do it. So like for certs in particular, like that's an issue of trust, and you're basically, since you're executing the module on behalf, so the runtime is executing code on behalf of the module, and therefore the host needs to be set up to trust certificates or whatever. So I think using the host to do that should be a good path. So like the host certificate store, I think Windows doesn't use files. They have some service or registry thing, I guess, to match those. So laying things down on disk that are platform specific are they're definitely interesting or weird to deal with. And I would definitely prefer to punt on that until like, almost like, okay, certs, yeah, we can just kind of use the host certs. Are there other things that we might need to pull into the root FS of the container? That's where things get weird. Could possibly do that with like volume mounts, which we should already be handling anyway. Yeah.
Yeah, I think we need to collect the use cases for that scenario before we try to design it. So that's where I'm at.
Yeah, and I'm trying to think about ways that it stays true to how you build containers today, container images today. So like when we lay down a container image today for a web app or something that's going to reach out to another web app, you're probably going to supply some cert bundle for it. If there isn't one already in that image base that you're using, right? It is kind of weird though.
Yeah, it's also almost like there needs to be something in WASM to deal with, like, for instance, TLS. Like, how do you set up that connection and enable, like, how do you trust certs in that case and stuff like that? I don't even know like what it does at the moment. I would imagine it's all just whatever's there, like whatever Go does, and if it when it's compiled to WASM, it's just read from the file system. But
And this is also with the expectation that TLS is happening in the guest. So
yeah,
the reason why this is currently with the runtimes that we have, TLS is happening on the host side. So we say, hey, go make a HTTP request outward. It comes down into the host. The host then actually delegates that call and then returns the result back to the guest. Perhaps in the future when we can, perhaps in future editions, we can, the guest is making that call completely, and maybe we can serve up to the guest as a component, like a virtual file system. So there's been quite a bit of talk about like packaging components that actually implement a virtual file system. So they basically are, handling file system access. You're packaging that up as a component. Those all get merged together and run at the end, and that's simulating that file system access.
So yeah, I don't know if I have a great answer for this right now, but
does WASM support making HTTP requests right now, or socket requests?
You could
think. Oh, sorry.
Oh, you can pass a socket file descriptor in, and then you
read
can
all of
use
it.
that, but it's gnarly. You don't want to do it right now. I think preview 2 support, Joe, correct me if I'm wrong, but I think preview 2 support should support that. So then that's actually, the guest is, binding to WASI. WASI is the thing that's actually doing it.
Yeah, I think especially for the case for certs, like it's going to have to be like a special component that is handling TLS certificates. Either that or it's just in the core WASI spec.
cool. So just moving forward, I'll wrap it up. Please take a look at the document, review it, give feedback. Should we set a time in maybe 2 weeks or a month to revisit any open questions? How do we move this forward? I did come up with a proposal here. The first phase was, right now there's no changes. Linux works. I can add Windows support, and we can have multi-arch images, and it just kind of will work. The second one would be to make the containerd changes proposed in here via annotations, which is what the proposal kind of outlines on how to do that. And then phase 3 would be potentially like changing the runtime spec and potentially bundle changes and really bake in containerd support instead of just using annotations and those types of things. But that's kind of how I saw it moving forward. But open to ideas.
Hey, James, when we introduce changes to containerd, do we need to reach out to the containerd folks and possibly present this work to their community meeting?
Yes. And Brian probably can help there too as well.
Yeah, Brian, go ahead.
Yeah, we could definitely do that. I mean, the changes are pretty minimal. Like it might be fine to just open a PR for that as well. One thing I really like about just using what containerd has already is it enables a lot of optimizations. Whereas if we're like, it'll be important to get it into the OCI spec just so it's not just containerd you can run this stuff. But it's also, it kind of removes some of the ability to do some of those optimizations, I think, unless we can pass down annotations or something like that in the same way. But even then, like, you still have to go and fetch the components. So it's like it's not a great place to have it, but yeah, that's like way down the road.
Cool. I did add a link to the demo that I did here in this document, as well as I think the prototype code is linked in here too, if anybody's interested in seeing what the changes actually look like. Brian, did you have anything else to add there? Sorry.
I did not. Let me
Okay.
get lower.
David, I think you were next.
I was actually going to ask Joji if you had any thoughts about it from like developer experience or from Docker perspective.
So I was just looking at the changes that James gave, and is this really all that's needed? Like just like slap a couple of annotations and everything works. If it's that, I'm fine with like with all of that. I was just thinking also about how to build such an artifact, and I added a question actually to the build kit team. I think it would be nice if also Docker could build those images. I mean those artifacts. But this just looks great. I'll have to try and make it work with Docker. See if I can like go from Docker to Containerd and see if it works. But this is awesome.
Go ahead, Brian.
Yeah, the build kit case is interesting because build kit is responsible for building all those manifests and everything. And so you can't just like build a front end to output whatever you want. So it's gonna have to be some pretty big changes to build kit, I think.
Yeah.
The way I generated these was I took your OCI tar builder, Brian, and I tweaked it to modify various ways. It's pretty raw, but that's how I'm generating these currently. So.
Yeah, the whole tar builder is pretty raw. So
All right, cool. I will hand it. Oh, Georgie, do you have something?
Yeah, I'm sorry. I just one last question. So okay, the Containerd side is kind of easy. What about the OCI side? How does all of that work? I mean, I know what the OCI is, but I never really looked at how adding stuff, changing stuff over there works. So how would that work?
Yeah, Brian, I'll quickly answer and then I'll hand it to you. So I made no changes to OCI currently. I just followed their guidance for artifacts and used it, which include changing kind of like media types. And then from a runtimes perspective, I just added annotations. So I didn't change anything from an OCI perspective. Go ahead, Brian.
yeah, at the moment, I don't think we know what changes could even be passed down to OCI. I have talked to them about potential changes to support this particular case, or not this proposal, but how can we support WASM modules and stuff in the image and distribution spec. And they're certainly open to changes. It's just a matter of proving them out before we put anything in the spec. That's the only hurdle. They really shouldn't be defining a new standard. They should be defining stuff that's already exists out there that's working. And that's kind of where we need to go from there.
Awesome. Do we have any questions on this task? Great. I'll go back to share my screen. All right, moving on to the next topic. I have added, how can we add preview 2 support in Run WASI? I put this question as an open discussion because I personally don't have an answer for this. But to provide you some background, Preview is coming probably by the end of this year, and Preview 2 is building on top of this component model, and Wasm currently has enabled supporting running and loading and running, executing Wasm components. So Wasm components is this kind of great, it's a bigger specification on top of the Wasm specification. And in Wasm component, you can define higher level types, as well as embedding like core Wasm modules into the component, and they call it like instantiation of a component, and that's a Wasm module. So WASI Preview 2 not only builds on top of the component model, but also has more APIs like the sockets API. But in order to have it fully landed in a way that you can just build your application in whatever language and compile to WASI Preview 2, the language compiler itself certainly have to support Preview 2. So that will take even a longer time. So this question, I guess I just have to clarify the scope of this question is for adding Wasm component support to run WASI, as well as how can we support the execution of Preview 2 enabled Wasm components. Anyone has any thoughts on this? Go ahead, Andrew.
So regarding to Preview 2, I think that one, just focusing on the WASI side about the expectation from the WASI system interfaces, like the ones that you mentioned about sockets and all that stuff, I expect that those bindings will be part of the Wasm time create or configuration, let's say. So I expect for those specific cases that at the time that this spec moves forward, those bindings will the same way that we are running WASI bindings today. Like we just go there and do, I don't know, inherit the STDIO and things like that. I expect that we can do the same with sockets. I'm not sure how that will translate into, for example, capability-based security and things like that. So if there will provide any kind of way to configure that or tweak that depending on what you want to offer to the model. But I expect that that could be one thing that we can assume that will be there. The other thing is that since the word or the width specification that it's tied to that specific component is also inside the component, I expect that maybe there will be some ability to auto-detect the bindings that need to be provided to that specific component. So I assume that that kind of work will be there at the time. But as you mentioned, the interesting part here, at least for me, and the challenge is the transition time. So what will happen in the middle? Like, will we need to support, or I'm saying like we, because many different projects relies on the same, will have the same challenge to detect what's the components that you can provide certain information, or for example, if we have new words or new types that a specific component, how runtimes will provide that to the component. I think those are the kind of challenges. I don't have the answer right now, but yeah, I think this is something that I think we are watching in different projects.
Yeah, that's a great point you raised, because as far as I'm aware, Wasm time is the only runtime that supports Wasm components. I think Wasm Edge is going to support it, but it's not currently implemented yet. And it's not, I don't know how long it will take them to adopt component model. So a second part to this question, I guess, is WASI, if we are going to support components, we have to also support, do we have to also support Wasm modules? If so, how can we detect if it's a Wasm module component, and how can we adapt from the WASM modules to the components if user give us either of them. Go ahead, David.
So correct me if I'm wrong, but I think there's a little bit of prior art in Spin on how they are taking components and then, you know, transforming or taking WASM modules, core modules, and then wrapping them as components when they come in. Is that accurate?
Yes. So Spin has to support the WASM modules prior to Spin 1.0. And so in order to do that, any WASM modules comes to Spin, they wrap it with a component and then execute in WASM time 8.0 something.
So I guess the corollary here is, do we want to support that? Do we want to provide that same support, or do we want to just upgrade WASM time and, you know, hey folks, this is how WASM time works, and it's just a way for we just surface WASM time.
As far as I understand, WASM time provides two sets of APIs, one for the module and one for the component. So if we are just going to use the component APIs, we have to change how we invoke WASM time currently.
And what is it, the first 2 bytes? Is that the first 2 bytes of the module? We could sniff the binary and determine whether it's a component or a core module, correct?
Yes, and there are tools like WASM tools to automatically detect that.
So I don't know about anybody else, but it kind of sounds like the nice thing to do would be to smell it and like verify which type it is, and then, you know, just branch from there. And Georgie, I think had mentioned 2 shims. Personally, it would be nice if we didn't have to make if people have to choose the right shim for it, it might be a little bit difficult from the user side. Like, hey, I'm going to go run a pod. I'm going to use run WASI, and now I have to change, like, say, the runtime class so that in Kubernetes it just like, okay, now it's going to use this one versus this one. Anybody have any thoughts on that?
So things to me should be, I guess, WASM module components or a module adapting to component. This whole process should be transparent to the user, and should also be transparent to developers for run WASI. So I think WASM time as the runtime should be able to detect modules and components and do this wrapper thing behind the scene.
Yeah, it's kind of like upgrading kernel versions. Like I don't want to have to tell people, well, you can only run this application on the older version of the kernel, and now you gotta, if you want to, like, you got to run 2 different machines to run the same sort of stuff.
Yep. Any more thoughts, questions on this one? Awesome. That's it for all the open discussions. Let me just ask if anyone has more topics to bring. This is your chance. Go ahead, David.
Thanks, Joe. In case anybody hasn't seen it, there is a working group for WebAssembly forming up in CNCF. If you're interested in getting involved in that space, please do. I absolutely would love to have all of your points of view shared and your expertise. So if you're not involved, please consider it. I know a few here are, a handful are. It's, I mean, honestly, a lot of stuff overlaps.
Yeah, thanks, Andrew, for providing the CNCF Slack channel. All right, give back everyone 10 minutes. Have a good day, and we'll see you 2 weeks.
Thanks, y'all.
Thank you.
Thanks.
Bye-bye.
Later.